So in the previous lecture, we have seen that if a grammar having more than one pass tree, then the grammar is ambiguous. So if the grammar is ambiguous, then we can resolve that ambiguity of few grammars by following two rules. Okay. So these two rules are, the first one is associativity rules and second one is precedence rule. So by following these two rules, we can resolve the ambiguity of a grammar. So let us understand the first rule, which is associativity rules. Okay. So let us suppose I am having a string id plus id star id. Okay. So this string, with the help of this grammar, will generate a pass tree that is T derives, star production is T plus T. Okay. Then we will take the second production, in which T derives T star T, and then ID, then ID, and here ID. So with this pass tree 1, I am getting the required string, which is ID plus ID star ID. Okay. So the same string I can get with this pass tree also, that is T having T star T, which is second production, and then T plus T, and then T ID, ID, and here ID. Okay. So with this pass tree, I am getting the required string. Okay. So I am having pass tree 1 and pass tree 2, and the grammar is ambiguous grammar. Okay. Grammar is ambiguous grammar. So one thing you have to note, that if the tree or pass tree is expanding itself along its right side, okay, T, then T derives this is, if the tree expanding itself in right direction, then this one is a right associative, and if the tree is expanding itself in the left direction, then we can say that the given grammar is left associative. Okay. So let us understand again. If I am having a production T plus S, okay, then this left hand side is equal to the leftmost element. Okay. When I am having this one and this one is same, then we can say that the plus is left associative. Okay, because this and leftmost element of the production is same to left hand side. And if I am having t derives s plus t, then left hand side element is same with the rightmost element of the production, then this one is left associative and this one is right associative, because the rightmost element is similar to the this side. Okay, so for following the associativity rule, we have to restrict our pass tree along left side. Okay, so by following this rule, this one pass tree is right and this one is wrong. Okay, so by following this rule, I have to restrict this grammar along left side. Okay, so by doing this, the resultant unambiguous grammar will be t derives t plus id, t derives t star id and t derives id. Okay, so by rejecting this one pass tree, I am generating the equivalent grammar which is unambiguous and following associativity rule. Okay, so this one grammar is left associative because the leftmost this element is equivalent to this one. This one is equivalent to this one. Okay, so here plus is left associative. Okay, plus, the plus operator is left associative, star is left associative. Okay, so this one is the first rule, and the second rule is precedence rule. Okay, so let us see the precedence rule in detail. For the same grammar, I am having the string id plus id star id. Then by taking this string and this grammar, I am having the following pass tree where t derives t plus t. Here t derives t star t and t derives id, id and id. One more possibility for the given string by using this grammar is that t derives t star t, then t derives t plus t, then id, id and id. Okay, so the resultant string I will get is id plus id star id, here same id plus id and star id. So grammar is again ambiguous, but here the case is that the precedence rule is not followed, because in this grammar I am having two operators. One is plus and second one is star. So here in this case I am resolving the star one first, and here I am resolving plus at first. Okay. So for resolving this problem of precedence, I am adding label to the grammars. Okay. So if any operator having high precedence, then I will add that protection to the next level. Or I mean to say that operator having least precedence will be at top, or will be at the start of the production. Here plus, for example, if I am in this string I am having plus and star, two operators. So here star having the high precedence and plus having the low precedence. Okay, then I will add plus to the start of the production, and star will be after that plus, or we can say that after the second level. So by doing or by following the rule of precedence, the resultant grammar I will get is T derives T plus S, then S derives S star, F, then F derives ID. Okay. So grammar is, by following the rule of precedence, I am changing this grammar to this grammar. Okay. So here star having the high priority, so I am adding this one star at level 1, level 2 and level 3. So the operator with least precedence, which is plus, I am adding that to first production or the start production, and the star which having the high precedence then plus, then I will add after plus. Okay. So the grammar I will get this, in the past tree for this will be T plus S, and after that S and F, F derives ID, and here I have to add S and F for this, the completion. So S derives F, and from S I am getting ID, and from T I am deriving S, from S I am deriving F, and F ID. Okay, so I am getting the required string by following the rule of precedence. Okay, so these two rules, by keep in mind, we can resolve the ambiguity of a grammar. Okay, so let us take few example The first grammar is B derives B dollar A and A. Okay. Then D derives D hash E and E. Okay. Then O derives O P and P. Okay, so in the following grammar, dollar is left associative because of this. Here the leftmost element or the left hand side element is equal to leftmost element of this production. Okay, so this one dollar is left associative. Here hash is left associative because this and this means left hand side is equivalent to leftmost element of the production, which is D and D. This one is also left associative. Okay, so same is here for O. O is also left associative because of this. Okay, so this is the associativity rule. And for the precedence rule, here in grammar, according to precedence rule, dollar having least precedence because it is added to the start of the production. Then after that, we can say that least precedence. Then after that, label 2 means hash having middle precedence, or we can say that high precedence than dollar. Then after, I am having high precedence of at the rate, and here is hash, and here I am having dollar. Or I can define the level of precedence for these operators dollar. Then I am having star, I am having at the rate. So least precedence is dollar. After that I am having hash, then one is this one. Okay, okay, so grammar is unambiguous because of associativity rule is followed in all three cases. Second one is unambiguous because rule of precedence is followed. A dollar is least precedence, then I have star higher than dollar, then at the rate higher than hash. Okay, so let us see one more example based on this. The example is I am having productions like E derives E star F, then E derives F plus E, then E derives F, then after F derives F minus F, F derives ID. Okay, E and E. So this one is the same production, and I will take it as level 1 and this one is level 2. Okay, so here which operator having the highest precedence? Okay, so here mine is having the higher precedence because it comes in level 2. Okay, so as per the rule of precedence, minus will having the higher precedence. Okay, and in case of star and plus, they lie in the same level, they having same level of precedence. Okay, thank you.